Well, hi and welcome to video 4 of Unit 1, Topic 1 from Specialist Mathematics. And in this video, we're really going to get stuck into permutations, finally. We're going to talk about unrestricted permutations, which are the easiest version and a good base to start at. By this stage, hopefully you've watched the first 3 videos, but particularly video 3, it's important that you understand factorial notation. I'll be using it pretty willy-nilly. Okay, so starting with unrestricted permutations. Let's look at an example. I have a team of 11 players in a cricket team. How many ways can I order this team? So you don't need to know anything about cricket to answer this question, and that's true of most contextual mathematics problems. In this case, we're told there's 11 players, and if you're given this an exam, you'll be told that a team has 11 players. So I'm going to order 11 players into a batting order, which means that I have 11 ways of choosing the first batsman. And then I have 10 ways of choosing the second, 9 the third, 8, 7, 6, 5, 4, 3, 2, and whoever's left over is the last batsman. So that's my setup of the problem, which means that the total number of ways, I'm going to cheat number and put a hash there, number of ways is equal to 11 times 10 times 9 times ... times 2 times 1, and we know that can be written as 11 factorial. And we throw that in a calculator and we get a number like this, 39916800. Yes, as I've said in pink there, factorials get big, expect them to get big. Now, it's important for us to recognise there are no restrictions on how we choose here. In real life, you're probably going to put your better batsman earlier on in the batting order. So if you knew the team, you would probably have more predictable choices, so there might be less ways of choosing that team. So, permutations of n things with only r chosen. This is really the main focus of today's lesson, or this video's lesson. So this time I have to choose my cricket team in order from 16 different players. There are 16 players to choose 11 from. So again, I've got this. 16 ways of choosing the first, 15 the second, 14, 13, 12, hopefully you're bored now, but I won't keep you for too long. Okay, and then at the end I've got 5 players that miss out on the team. So the number of ways of choosing this team, which is going to be even bigger, is equal to 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6, down to 6. And you might be wondering why I didn't use my famous ... here. Well, it's because I really wanted to show something, and that is that this could also be written as times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1. And in fact, there's always going to be 16 factorial ways of choosing this team, but at this point where we stop choosing. We don't need to have that times 5 times 4 times 3 times 2 times 1. So instead of doing this long calculation here, which would be far worse if we were choosing, say, 100 people from 500, we can write this in shorthand as 16 factorial over 5 factorial. And the denominator here, the 5 factorial, in essence, cuts the tail off the 16 factorial, which is really handy and makes our notation and calculations quite a bit easier. So of course you're probably interested to know what this number looks like, and we know it gets big, so we get 174 356 582 400, which is not actually that big. So that is 174,356,584,400. So I've already been through this. This can be written as 16 factorial over 5 factorial. And of course, this is where we get what we call our permutation or our P notation. NPR is equal to n factorial over n minus r factorial. So the way I'll say this, and a lot of teachers say this, is I'll use the verb pick as our P word. So we say n options, pick r of them. In this case, we had 16 options, and we wanted to pick 11 of them. And so we did 16 factorial over 16 minus 11 factorial, which was 5 factorial, leading to this. Now, this could be written as NPR like that. Could also be written as NR. No, so my lie. That's for C notation later on. But this NPR is more common. Now, you're probably using a Casio. So in a Casio, to evaluate 7P4, here's your run through this. I suggest you go through and check my answer, which is there, on 16 factorial over 5 factorial, using the NPR notation, NP or 16P11, to get this number, and see that you can actually do this. So a permutation is an ordered arrangement of things, R chosen from N things. In our next video, we're going to run through some examples of this. So tune in and we'll see example 2 and a further example 3. All the best.